everyone. I am Sakshi and we'll be taking your maths class and we will be starting your fourth chapter according to your NCRT. That is the basic geometrical ideas, right? So let's start with this. So in this chapter, you will be learning the basics of all the geometry, right? So here you will be learning with some specific definitions. You might be thinking that this definition is not of use and this and that, right? But later on this definition will always help you to do the questions of the geometry. Right now this is very basics, right? Really very basics. Only you will be learning the terminologies, what are it, right? So later on this will become a part of a question, just a single one word in your question, right? So you should must aware of what the like what it is, like what it is talking about, right? So whenever you heard some these type of the terminologies which are being used over here, so you should be like very clear about it, what it is talking about. Nobody is going to say you what does this terminology means in later in your like in your higher classes as you move to your higher classes. So this is like basic geometry, basic geometrical idea. The topic itself relate, it's a basic geometrical idea. They will only give you the basics terminology, that's it, right? So let's start with the topic. Okay, just a second here. Okay, so we will be starting with the basic geometrical ideas, right? So I'll be writing the notes and everything very clearly. So you just see, like we'll be learning, like first things we'll be learning over here is a point, right? Okay, so I think so everyone knows what is a point, right? Point means generally point means what? It is like it is point is almost an invisible dot which can be determine a location or a position but cannot be extended. Right now, can you see the cursor, the pen right now? I just made a dot, right? So this, can you see this? Can you see this, right? This is what? This is what? The outside one is a circle, but this one is what? A dot. But if you take a like a nib of a pencil, right? If you take any nib of your pencil, right? The nib, right? The nib over here, this is what? A dot, right? You see the nib of this pencil is again a dot, right? So you have been seeing that if you just play any game, like if you play, let us suppose you play Monopoly or something, any other game, you see that you locate yourself, right? This person is standing over here, this person is standing over here. So particularly you denote the location or something with a like a person position with a point, like CA is standing over here, B is standing over here, C is standing over here, D is standing over here, and E is extending over here, right? Basically the point right now, point is almost an invisible dot which can determine a location or position but cannot be extended, right? So point is something like that which is like which does not have a length, which does not have a breadth, which does not have a height, right? So point is like the point does not have any dimensions. Dimensions means what? It does not have length, breadth, and height. You might be hearing like it can have length and breadth. No, it does not have length and breadth. Nothing, right? So point. So basically, a point means what? A point determines a location and it has never a thickness. So basically, this is a node point, right? That is a point. A point determines a location, right? Location. It has neither, these are important points, I'm saying it's not written, it has neither length nor width. Length means what? This is the length, right? Width is like this, right? Neither the width nor the height, right? Like height, I'm standing, this is the height, right? So not the height, right? Nor height, right? Right? Point is being like point, it is denoted by, point is denoted by beta what? Denoted by a capital letter, like capital letter, by a capital letters or by a name, like or named as a single point or a cap by denoted by capital letters. Yes, by capital letters. Okay, capital letters like you see over here, capital letters X, right? Y, A, B, C with the point over here. This is a point A, right? this is point B, right? If I say comma point X, this is point X, like this it is written, right? So point is nothing, just a like it does not have length or breadth or just a simple dot, right? Dot, that's a point, right? Now coming to the next slide. What is a line, right? Now coming to the line, if you see that a line is a combination of a points that extend indefinitely, like you will say, ma'am, the point can go like this, like this. No, it means what? A point has to go in the same direction, like in a straight line, right? It has don't have to go like this, like this, like this. Point can go like this. If you see that you have so many points, you can just point, make a point, 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 point. These are what points. But what is a line? Line is a combination of a point that extend indefinitely, infinitely in both the direction. A line is labeled like a line segment with a bidirectional arrow over the label, right? I think so. This is going to be a really tough definition, right? A line means what? That is, a line has only a length which has been extendingly, like endlessly in both the direction, right? Right. Um, yeah, it is like that. If you take a straight line, like if I take this pen, right? If I take this pen and I'm going to extend this on the left hand side and on the right hand side and keep on extending this line in a straight line, I'm going to extend this on both the side, then this will be a what? A line. A line is a straight. A line is not a curve like this, right? If you see, like if you're going to take a thread and roll about like a ball, no, it's not a line. Line is always a straight line. It's a straight line. It's always a straight, right? So we can say that a line has a thickness. No, line does not have a thickness. Line have only what? A length. Because you will be just measuring it. Yeah, it will be going in this direction only, right or not? Right. So I think so. This definition is kind of tough, but I'll write a simple definition for you. Right. It's a bidirectional. Bidirectional means what? In both the direction, both the directions, right? So line cannot go. If a line is going this way, so it will be like this, or the line is going like this, right? In this way, right? It is going horizontally or the vertical. So in nursery classes, like I think so, your teachers or maybe your parents have taught you how to make a vertical line, how to make a horizontal lines, so that you can make A, B, C, D, like the alphanumerics, right? So this is how this comes. So this is one of the definition, right? You can write, and this like how I'm going to write, and you can see that how the line has been formed. If you take a paper, like if I take a sheet of paper, let me just see. Can you see this sheet of paper? Can you see the sheet of paper? Right. Can you take a sheet of paper and just take a fold of it, right? If you're going to take a fold of a paper, right? If you take a fold of a paper, you see that a crease has been formed, right? This crease is what? A line. This crease is what? A line, right or not? This crease is a line. If you can just make us like, if you can make like this also, it's not like that you have to make always divide in an equal half. You just fold anywhere, right? If you fold a sheet of a paper, you always find a line or not. Yes or no? It means the joint of the two, like if the joint of the two sheets of paper will always be a line or not. Yeah. Yes or no? So this will be a what? A line, right? So you can see that if you fold a paper, you always get a line, right? So when you fold any like a flat thing, right? Any, if you fold anything that is which is a flat, you fold it, or either if you join this, right? If I take one sheet of paper and the other sheet of paper, like let us suppose if I'm going to join these two sheets of paper, right? So the joining point of these, can you see this? I think so it's visible, right? So if you're going to join this, the line over here will be what, beta? This is going to be what? A line, right? This is going to be line. But you will say, ma'am, it is having only just a fine. Yes, right now it is here the length is defined, right? But actually this is what? ये पूरी तरीके से it's going what? Infinitely in both the directions or not, right? So here I'm just taking a simple example, just a simple example. Yes, this sheet can be what? A very big sheet, right? Right now it's a small sheet, so here we are working on the small sheet only, right? So we'll write it down, right? What we will write it down, the important points is that a line has length only, right? Length only. It has no breadth and or thickness. right? Uh, yeah. So we can say that the length, that like how this line has been indicated, the line has been written like this, right? So how it is denoted, it's denoted like this. If you take a line like this, it is denoted, it is like denoted or written like this, it's denoted or written like this, right? Written, you draw these two lines, right? If you see that the road is going like this, so either you take any alphabets with a small letter, right? Any small letter, a b c d e f g h i, whatever you feel like. So I'm writing this as L, so it is can be written as what? Line L, right? Line L. Or either you can take any 2 points on it, either you take any 2 points on it, like A and B, any 2 points. So how this has been denoted? It's denoted like A, B with the arrow on it, right? Or you can go from B to A. It is never saying that you have to go from left to right or right to left. You can always go from either of the way. You, if you feel like you want to go on the left to right, you can go left to right. You want to go from right to left, you can go to right to left. This has been denoted like this, right? And if you take any line, right? If you take any line, right? So if you take any 2 points on the line, like A and B, there will be definitely some point lying on like between them, or like here, like between AB, yes or no? Yes, so you can write line AB, you can write line DC, you can write line DB, you can write line AC, right? Whatever you feel like, right? You have to just take the 2 point to take the denotion, and there will be always a point lying between the any 2 points, right? So we can say that line is consisting of, as we seen in the previous slide, the line consists is a combination of a point that extend infinitely in both directions, right? So a line is made up of what, beta? A small, like taking all the points in like this, 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 and a line will be formed, yeah, in one direction, not like this in a doodle way, right? So we can say now one more thing. Can I say that the length of the line is what, beta? It's, can you count? Can you tell me what is the length of a line? If it's going infinitely, like it's going in both the direction endlessly, so can you tell me what is the length of a line? The length of the line is be not, beta. It cannot be determined, right? Or we can say that it's unlimited, right? So we can say that the length of the length of a line is unlimited, right? Or we can say that the line it says that the line is made up of, that is infinite. Infinite means what? Uncountable, right? So these are the simple terminologies that you will be learning this year, right? Uncountable, number of points, right? Number of points, right? I think so is good to go. Now, what is a line segment? Line segment, can you see that if you're going to take a very, very big line, if you just take a small part of it, it will become a what? A line segment. A line segment means what? A line can be drawn between the 2 points is termed as what? Line segment, right? If like right now we have seen that A and B and C and D are the positions, that these are the points, right? Then we have seen that the line is what? It's going infinitely, right? So as I have shown you on a sheet of a paper, that this is what? A line segment also. But if you're going to extend this endlessly in the left hand, in the right, in the upward direction, in the downward direction, it will become a line. So right now what I did to make a line segment, I just make a like cross section. I just cut it, not a cross section, I just cut it, right? So right now I know where it is starting and where it is ending. Basically a line segment is what? that a line segment can have or like a definite length, right? A line segment can have what? A definite length. And line segment is a part of what? A line. If you're just going to terminate the line, if you just take a small part of a line, that it will become a what? A line segment, right or not? Or if you take any 2 points in, like if you take any point over here and if you take any point over here and join these 2 points, right? So this is going to be a line segment, but in a straight line, not in any way, right? You can go, if I say this is like A and this is B, if I say from go to A to B, you can go from A to B like this, like this, like this, like this, like this, like this also. Or you can go from A to B like this, like this, like this, like this. But if you're going in a straight path, right? Going in what, beta? A straight path, then we say that it is a what? Straight path. Then it is what? A line segment. It has its initial point and it have a what? Final point. Generally you will learn this word in your physics, that is a displacement. Displacement is the shortest distance between the 2 points, right? So this is a point A and this is a point B and this is called a displacement. Let us suppose right now I'm sitting in a Noida and I want to go to Agra, right? So I can go to Delhi to Agra. There are various routes I can follow. I can go to from Delhi to then Lucknow to Agra, right? There is a direct route of Delhi to Agra. So which is more preferable? What is the total displacement? Like where I have displaced. So my initial position was Noida and the final position is what, beta? Agra, right? So here that I went in a straight line. So this is known as what, beta? A line segment, right? Later this thing, what I'm telling you, this will be more relatable to physics, but this is known as what? A line segment, right? A line segment has a what? A definite length? Yes or no? A line segment have a what, beta? A definite length. Let us suppose if I denote this is a line, right? This is a line A and B, right? So either you can go from A to B or B to A, right? A to B or B to A, and you know that it is like fixed, right? So can I say that AB can be written as like this, a line segment, right? Or you can go from B to A. Nobody said that you have to go from left to right or right to left, doesn't matter. You can go from either way, right? It is denoted like this. So, and one more thing, like if I say, if two line segments are equal, right? If two line segments are equal only when their lengths are equal, only when their lengths are equal, only when their lengths are equal, right or not? Yes or no? So can I say that the lengths are equal means what? If you're going to take any line segment like equal, right? If you take that or we can say the line segment, this is line segment A, this is line segment B, and this is line segment C, and this is line segment D. So I can say that AB is equals to CD means what? Their lengths are what, beta? Equal. Their lengths are equal, right or not? Yes, if this is 5 centimeter, let us suppose this is 10 centimeter. So this one is also what, beta? 10 centimeter. These are what? Equal. So we can say that a line segment is what? Can have a definite length? Yes or no? So we can say that a line segment always have a definite length. A line segment always have definite length. Right? Definite length. And this you can draw on a sheet of a paper. See, a line can be drawn on a sheet of a paper. No, a line exactly cannot be drawn on a sheet of paper. We just indicate it, right? But a line segment can be drawn on a sheet of paper. We can always draw a line segment on a sheet of paper, but we cannot draw a line on a sheet of a paper because this is like a very big thing. It's going endlessly. You don't know where it's going to end. So it's keep on going on the left. It's going, keep on going and keep on going on the right. So you don't know, right? Okay. Okay. If I say in a line segment, this is a line segment A, this is a line segment B. And I said that N is the midpoint. N is the midpoint of AB, right? So it means what? The length of AM is equals to what, beta? Length of BM. Yes or no? Yes, you can just make an arrow like this, right or not? So can I say this also that, can I say that the length of AM, also can I say that the length of AM is equals to what, beta? Half of, like 1 by 2 of AB or not? Similarly, the length of BM is equals to 1 by 2 of AB, just half of AB. Yes or no? Or you can write half of BA. You can write either of it, BA or AB, right? AB or BA, whatever you feel like. So it doesn't matter you write AM or you write BA. Nobody said that you have to go in this specific direction. So this can be what? BA, or it can be what? Half of BA. That's it. Yes or no? No. What do you mean by an intersecting lines? Right now, we have just learned about what are the lines, right? Now, if you take two or more or three lines, then it can be what? The two lines are what beta terms as intersected when they cross each other and share a common point, right? Now, let us suppose if I give you like two pens, like this is a two line. Yeah, you can have two intersecting line or you can have two intersecting line segment. Both are same. But line segment can have a definite length. But this is like the two pens. This is what? A two line segments. But if I say that this is a line also, if I just extend this pen on both the direction and this pen on the both direction, so this will be a what? A line, intersecting line segment. So if I'm going to see, if any time if I give you a line, two lines, what is the common, like how many common point they will be sharing? They will be sharing only one common point between the two lines, right? Let us suppose if I give you, let me take one more pen. Like if I say this is the third pen, right? Can you see this? I think so it's visible, right? So if I say like this is what intersecting at the 2 points, right? 1 point, like what is the one common point? Now, if I say that this pen can intersect this pen in the 1 point, right? This pen at the other point, yes or no? And this over here, that it will be what intersecting like this. All of three will be intersecting at the 3 point. So any two lines, if you take any two lines, they will always intersect at a common point. That's only a common point. I've signed not the common point. Like there will be no many common points. There will be only a single point that they will be intersecting. You have been seen in a railway trains, right? You have seen like how the trains go, and if you see the roads also, right? So if you take a book or something like this, if I take this is a sheet of paper, right? So can I say that this line, if I'm going like this way and this way, so this is what, these two lines are what, intersecting? Yes or no? They're intersecting at this point. They're intersecting at this what, this is what, a common point, right? So this is known as what, intersecting line. If you see that many figures, you see that the two lines are termed as intersected when they cross each other and share a common point, right? So if you just take a line like this, right, this is a point L, and if you take this a point M, this is a line M. So what is this? This is a what, a common point. Hmm. This is what, a common point. Yes or no? Now let us suppose if I draw, let me change my color. Just a second, I'll just show you. Just a second. In color. Let us suppose I drew a line like this, right? So this is a line N. So this is intersecting with the M at this point. And let us suppose if I'm going to extend the line L, it is going to intersect at this point or not? Yes or no? So you will always see that every line, if it is intersecting, they will always intersect at a common point that will be a single point. So can you see in this figure, this and this are what, intersecting points? Yes or no? This is clear to everyone. This is what, a common point. This is, again, there's my cursor. Okay. This is what, a common point, right? This is what, common point, right? Common point, right? And this is again a common point. Okay, now coming to the parallel lines. Parallel lines are what, which never and ever intersect. This is like you see in your day-to-day life a lot of times, right? So you say that two lines are set to, let me change my color, it's too light. I'll take red, that was a nice color. Okay, you say that two lines are said to be parallel if they are in the same plane and they will never intersect. Now you will say, ma'am, what is a plane? Now we'll discuss this in the next class. What is a plane? It means what? Like if you are going to take this line, right, this is what it's lying in a single sheet of paper. Like if you see that all the lines that if you take any ruled sheet of paper, that the lines are what parallel to each other. If you pick this line and if you pick this line, these are what parallel to each other but like very far from each other, yes or no? Yes. Or you can take a ruler, or if I take my phone, right, if I take my phone, so this side and this side is what parallel to each other, right? They will never and ever intersect. If whether I extend this line on the upward direction or in the downward direction, this are never going to intersect each other, right? Let us suppose if I take this also on this side of this like this, so this will what never intersect each other. If you see that the railway, right, when you travel on a train, you see that the tracks are always parallel when it is running, right? It's always parallel, right? So the tracks are always parallel when the train is running or not, right? They will never and ever intersect. Like if you see the screen, like if you take the screen of a window, that these two sides, like if you take in a book, right, whatever, if you take a book or anything like this, so this will be what never intersect. Yeah, you say that this is what never intersect. This and this line is parallel, and this line is parallel. Or can I say that this line and this line is parallel? So I make an arrow. This is line L and this is line N. So it is denoted like this, beta. It is denoted as L is parallel to N. This is a symbol of small symbol. L is parallel. This is symbol means what? Parallel, right? L is parallel to N. Like let us suppose if I give you a figure like this, like this, like this, like this, and like this, right? Now you see, can you see that I'm writing this line as L, this as M? Oh my bad, my bad, my bad. I'll write this as M, this as N, and this one is as A, right? I'm making this an arrow. Can you see that which two lines are parallel? Can you see that the line, I'll tell you how, like which two lines are parallel. Like would like tell me the lines that tell parallel lines, right? If I'll say what are the parallel lines over here. So what are the parallel lines? So if you see that parallel lines is what beta? L and M. So if you're going to see like if such type of figures are given, so always indicate by an arrow, right? So parallel lines are indicated means what? I'm making a single arrow for this and this. So line L is parallel to line M first, and the second is what? Line N, I'm making a double arrow, and double arrow indicate means what? These two lines are parallel. If nobody has written that these two lines are parallel, but the arrows are made, you can definitely understand that these two lines are parallel. So these are the small, that's why it's called basic geometrical ideas. So we can say that N is parallel to A. That's it, right? So this is how we denote it, right? Now coming to the perpendicular lines. Perpendicular lines means what? Like you have seen that the two lines are said to be perpendicular when they intersect at 90 degrees or right angles, right? So you have heard about, like later on we'll be learning about what are the right perpendicular lines. Perpendicular lines means generally means what? If you take any two lines, this is like very clearly you see in your like day-to-day life, right? If you take a sheet of paper, right? If you take this sheet and this sheet, right, this line is intersecting and this line is intersecting. So what is the angle made over here? What is the angle made? The angle made over here is what, beta? 90-degree, right? You take like a book, like a top of a book. The top of a book cover will be what? All the corners will be what? A 90-degree. Yes. If you take a top of your table, it will be what? Again a 90-degree or not? Yes or no? Yes. So anything which is being perpendicular, it's said to be a what? A perpendicular line set. If you take any two lines, like let us suppose I'm taking this line and this line, right? These are the two lines or a line segment, and they are intersecting. It means what? At 90-degree. Right now, in the previous slide, we have seen that the lines were not intersecting at, they were intersecting at any angles. Angles were not very much specific right now, but when the lines are intersecting specially at 90-degree, we say that these are what, beta? Perpendicular lines. That is the point of intersection. What is the angle? Right now if I make a like this and like this, so it is intersecting. You don't know what is the angle over here, you don't care about the angle, yes, but we say that this line L and M are intersecting. But like right now if I make a line like this, right, and I make a line like this, right? Yeah, so they are intersecting over here, right? This is a common point and they are intersecting at 90-degree, right? So we write this as line M and this is line M, right? This is a simple way. So we say, how we say, that is how it is denoted. It is denoted by like this. It is denoted It is denoted by L is perpendicular to M. These are the small little basic symbols that you should be remembering. For parallel line, this is a small little symbol, right? Perpendicular lines, you write L is perpendicular to M. These are the small symbols, right? So we say that this is what beta, perpendicular, perpendicular. Right. If you see this figure, what they have done, they have taken the two scales and put it at what? 90 degree to each other, right? They're making 90 degree to each other. This is an angle, right? So basically, that is two perpendicular lines are said to be like two perpendicular lines when they intersect. The two lines are said to be perpendicular when they intersect at 90 degrees, right? So it is denoted by L is perpendicular to M. We can say like this also. We can say like this. Like if I'm making a line like this, it is a what? A line segment. I'll make a line segment. This is a line segment, this and this, right? I'm writing A, this as B, this as C. So can I write this as AB is perpendicular to what? BC. This is the symbol how we denote it. Good to go with everyone? Yes. Now coming to the ray. What is in ray? Ray is mean right now I'm using a heater. It's cold over here, and you not heater. You can see that a sun, you have been using, like we know what is a sun is, right? We know that what are the tube lights and the bulbs are, right? So when you illuminate, like when you just turn on the switches, you see that the light is coming, right? So light never comes in like this. The light always come in the form of a ray. So when you see sometimes in a sunlight or something, like the rays are coming like this, just notice it, right? So you know from where it is originating. A ray can be defined as a straight line, not like this. Ray means what? Never like this, like this, like this. It's a straight line. We are talking about everything in a straight line. It's a straight line that start from a point and extend indefinitely in one direction, right? In one direction. So can you draw a ray on a sheet of a paper? No, you can never draw a ray in a sheet of a paper. Ray is means just like this. This figure means what? This is a torch, which you know that it is been originating from here. Originating from here, beta. Originating from here, and it goes endlessly in the endlessly in the other direction or not, right or not. So you know what is the ray. Ray means what? You know where it is starting, right? You know the starting point and you don't know the end point. Or you can write like this. You can like this is the starting point, it's going in the end direction. How it is denoted, beta? If I write this point as A and any point as on B, right, and this point as P and this point as Q on it, right? Always a ray is a straight line. Intersecting lines are straight lines are straight lines, right? Everything straight. Right now we do not doodle, or we do not go in like this direction or any other of direction. Everything is a straight. Everything you're turning, walking straight only, right? So how it is denoted? It is denoted like you're starting from A and going to B. So can I write this as A to B? But we cannot write, cannot write like this. B to A. We cannot write. This is wrong, right? Because you know that it is starting from A and going towards the B. Similarly, you will write this as PQ. It's starting from P and but not QP. This is wrong. This one is wrong, right? Acha. The length of ray is defined. The length of ray is what? Defined or not? The length of ray is unlimited. We can say because we cannot draw in a sheet of a paper. The length of a ray is what, beta? Undefined, right? Yeah, फिर unlimited, we can say that. It's better we write unlimited, right? Unlimited. Okay. Yeah. So we can say that so you might be thinking that ray always start. Now let us suppose this is a originating point. A ray can go like this, 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 a ray can go like this. If I say this is a point A, this point B, this is C, I'll name this as B, this one as C, this one as D, and this one is E. Right. So can I say that OA, OB, OC, OD, OE are what? Rays? Yes or no? OA, yes. OB, yes. OC, OD, And OE are what beta? Ray or not? These are rays. Yes or no? And it's originating from O. Right. Now, can I say that if I just make an arrow like this, and this is like where I know this is the point which is going. So can I write this as O point and this point as P and this point as Q? So can I say that OP and OQ is a ray also? But it is a straight line, right? You can go in a straight line, it cannot be a straight line. So can I say that OP is a ray? And we can say that OQ is a ray? Yes or no? Yes or no? I think so this much is clear to everyone. Okay. Okay, what is a plane? Right now, let's see what is a plane. Right now, we have just learned about that is two lines are said to be parallel when they never intersect each other in a plane. Right. So plane is nothing, just anything which is a flat. This is a flat sheet of paper. The flat curtains behind me. I cannot show you the curtain right now. The curtains, right? If you take a bed sheet, it is what? A plane or not? Yes, it have a length. It have a breadth. Length means what? This is the length. Yeah, this one is your length, right? Right. This one is your length. And can I say that this one is your breadth? Right or not? This one is your breadth. So can you see that this is a flat surface? Right or not? You see that this is a flat surface, this is a flat surface, this is a flat surface. So if you take any of your book or if you take any of your laptop, if I take my phone as well, right? So these are like so many surfaces, like one surface is two surfaces at the back, this is the third surface, this is the fourth surface, this is the fifth surface, and this one is the sixth surfaces. So surface, flat surface means what beta? Anything which is a flat. अब ये है कि let us suppose if I take the bed sheet right now, you use a bed sheet of like 6 feet, right? 6 feet by like 6 feet by 6 feet, right? Yeah, 6 feet means what basically 72 inches, right? 72 inches by 72 inches, right? But can I take a cloth that is a flat cloth which has been extended like going endlessly in both the directions or not? A flat surface. Can you extend this is in this direction, this one is this direction, and this one in this direction, and this one is in this direction, right or not? Can you go? Yes, definitely you can go, right? So it means what? A flat surface cannot be a very much specific. You just cut it, right? So right now, if you take a top of your table, this is what? A flat surface, right? If you just take a bed sheet, it is again a flat surface. If you take a top of your laptop, it will be what? A flat surface. Yes, a top of it. It should be a like a length and a breadth. Like if you see like a rectangles or anything like this. So if I take like a book, right? If I take this book, can you see this book? And if I take only this surface, right? So this is what? A flat surface, right? This is what? A flat surface. So flat surface means what? Which have length and the breadth. It does not have thickness. Thickness means what? Thickness is negligible. Right now, whatever we use, it's like negligible thickness. So we say no, right? So a flat surface is a surface which have a length and a breadth which extend endlessly in both the directions, right? So yeah. So first write down the definitions of a plane. Yeah, the flat surfaces are known as planes, like we say that. Flat surfaces, they write this. A flat surfaces, surfaces are known as planes, right? Second, a plane has length and breadth. Breadth, it has no thickness, right? The basic concept of a plane is its flatness. It has to be flatness, right? Flatness, and it extend indefinitely. Indefinitely means what? In the both directions, right? Indefinitely in all directions, right? In all directions. So can I say this also in this direction, right? This one flat surface in this direction, right or not? In all direction, right? Okay, so how this has been denoted? This has been denoted like this. If you take a flat surface, right? So I'm taking something like this, a flat surface. So you just write down the if you just write down the P, right? Or anything like this. So it will be what? Like this. So this is represented as what beta? Plane P. You write as a plane P, or you write this as plane Q, right? Plane Q. Or similarly, we can just a second. Let me please right. So can you see this also like this? That I can just take any 3 points on it, but it should not be in a straight line, right? So I'm naming this as A, B, and C. So this can be written as what beta? Plane ABC, right? The line points has to be like not in a straight line, right? So this we say that this is a plane ABC, right? Okay, yeah. Now, okay. So one more thing, that's the length. Can I say if the length and the breadth of a plane are unlimited because it's extending, right? You're just taking a part of it. As you take a line segment is a part of a what? A line. Similarly, a flat surface which has been extended, just you take a part of it, right? So it's what? Unlimited, right? Unlimited, right? This is clear. This one is clear. Now let's go on the next topic. Now let me change my color once. um Yeah, write down this heading. The properties, sorry, the properties of, write down this heading. Properties of points and lines in a plane. So here we'll be learning with some important points. So first is this property. That's property one. First write it down. What is a property? Then I'll explain it to you. Okay. And unlimited numbers and unlimited numbers of lines can be drawn passing through a given point. Yeah. Now, if I give you this point, right? This is a point P, right? How many lines can you draw with passing through this line? Can you draw? Can you draw? Yeah. You can draw a line like this. I'm drawing a freehand, so try to understand my feeling, right? Can you draw a line? This is going in a very bad direction. Wait a minute. I'll try again. I'll try again. Just a second here. Okay. Uh, yeah. Can you draw? I'll just draw small lines, right? Because I'm using a freehand, right? Can you draw a line like this? Yeah. Can you draw a line like this? This you have been done in your childhood also, right? Can you draw a line like this? Yes. Can you draw a line like this? Right. Just shorten up, right? So can you draw unlimited numbers of the line can be drawn passing through a given point, right? So I'm naming this as L, this is M, this is N, this is P, this is Q, right? These many lines are there, right? So line L, M, P, Q are what? You can draw many lines for this, right? Coming to the property 2, right? Property 2 is what? Property 2. Okay. It says that there is exactly exactly one line passing through passing through two distinct means what? Two different, right? You can say that this 2 points, can you see my hand, this and this are my two distinct hand. But if I say I'm going to merge my hand, this is what, like, there's no distinctness, right? You cannot say like these are the two distinct points, right? So you have to see like two different points, right? So two distinct given points in plane, given points in a plane. Yeah. Let us suppose this is a point P and this is a suppose a point Q, right? This is P and this is Q. So we last in the last thing we have just seen in the last thing we have just saw key from P infinite lines can be passed, right? So you can draw like this, you can draw like this, you can draw like this, right? And from the point Q also infinite lines can be drawn, right or not, right? Yes or no? I'm drawing like this. So like this you can draw, right? But there will be only one single line. I'm just right, like let me make this. There will be only one single line which will be only passing through P and Q. Let me change my color. Okay, so if you're going to join this, there will be only one single line which is going to join P and Q. Only one single line, right? So it's going to be end like this and it's going to be like this. This is difficult. Draw a line with a fair free hand. Just a second here. Okay, so you just extend this in this direction, right? So this is like basically this is PQ. This blue line is what? It's only a one line, right? Now coming to the property 3. Okay, two different lines in a plane either intersect intersect at at exactly one point or are parallel. Right now, if you say that if you take two different lines in a plane, there will be two types of the line in the plane, right? See, we are not talking about right now being like very specific. See, perpendicular lines are intersecting lines. So we do not talk about like these are lines going to be perpendicular at any angles, right? So we have to be like very much specific that they are intersecting. Angles doesn't matter, right? So if you are going to take any lines, any two lines in the like plane, like right now I'm drawing in a sheet of a paper. This is again a plane, so there will be only two possibilities. Right now we have just learned that two lines can have only share a one common point. That is known as what be the point of intersection or a common point, right? So if I take any two lines like this, so these will be what? Intersecting, right? This is line L and M, or otherwise this line can be what? Parallel, right? I can say this is a line what? P and Q. Yeah. P and Q are what? Parallel. So in a plane, there will be two types of the line available. You can just draw a line like this also. Yeah. I'm going to make a line like this. So I'm naming this as A. So can I say that line that is A and P are what? Intersecting. A and Q are intersecting and P and Q are what? Parallel to each other. Yes or no? So can I say that over here? I'm just writing over here that A and P, one bracket, and A and Q are intersecting? Yes or no? Are intersecting, right? And we can say that P and Q are parallel. Yes or no? You can draw a line like this also. Yeah. So there are various ways you can draw a line, right? Coming to the fourth point, right? Okay. Property 4. What are collinear points, right? See, these are the terms. I know you will be thinking ma'am is teaching just the terminologies and this and that, right? So what happened when you will be learning these things now later on, the collinear point, concurrent points, they are like, just we say that the points are collinear. Then you ask your teacher, ma'am, what are the collinear points? I forgot it. Right. So this is your expression. I have seen students, this is my experience, what I'm talking about right now. So they do such stuff, right? So do please, please, please just memorize these stuff. Don't take it lightly. These are important terminologies that you are learning right now. Okay. What are the collinear points? Okay. I'll write down the definitions, right? Three or more points in a plane are called collinear points if and only if and only if all of them lie on the same line, right? Now this is a catch point, right? Now collinear points, please beta, this is really important. Now be like, listen very carefully, right? If I'm saying I drew this point, I drew this point, I drew this point, so if I'm going to join these lines, this is not going to be a straight line, right? But if I'm going to draw or like take this point, this and this, right? Like, so if this I'm going to draw like joining all the 4 points, a straight line is formed or not? A straight line is formed. So when you join all these 4 points and a line is formed, then we say that A, B, C, D, then we say A, B, C, D are collinear points, right? So it means what? When you join all three or more points in a plane, they are said to be collinear when they lie on the same straight line. Or either you just join all the three lines and a straight line is formed, no bending is there, nothing is there, no intersection is there. So right now, this is no. Big no, right? Now let us suppose if I take another point, right? So I'm naming this as P, Q, R, S. So you will say that, ma'am, PQ is a straight line and RS is a straight line. No, PQRS, that they all have to be what, beta? They all have to be in a straight line. Right now, PQ is in a straight line and SR is in a different straight line. They are not in the same straight line. So these means what? They are not collinear points, right? Now coming to the next property, that's the property number 4. Property number 5. Now you will be learning about what are the concurrent lines, right? Concurrent. Again, concurrent lines. Ask someone of your like 8th grade or 9th grade, they don't know what are the concurrent lines. I'm giving you the guarantee. Ask your like seniors or this and that. Most of you, what are the collinear points? Like, I'll not say like all of them, right? But most of them, they forget what are the concurrent lines, what are the collinear lines. They'll say, oh, what it is? I have never learned about it. But these are taught in class 6, to be honest, right? Okay. So, okay, we say three or more lines in a plane in a plane are called concurrent lines if and only if all of them all of them passing through the same point and this point is called point of concurrence. Is called point of concurrence. Point of concurrence. Please mark this point of concurrence, right? So let us suppose if I draw a line, right? Let us suppose if I draw a line like this, like this, like this, like this, like this, right? So can I say that line L, line M, line N, line P are passing through the single point? Yes or no? Yes or no? So this point is known as what, beta? This point is known as what, beta? Point of concurrence, right? They are like intersecting at, all of them are intersecting at a single point, right? Point of concurrence, right? But if I give you one simple example, ये और ये मैंने कुछ ऐसी line बनाई, right? एक line बताती हूँ, right? Okay, so I'm making the other line like this, right? So can I say that this is a point of concurrence? Yeah, this one is a point of concurrence, but these, everything is like, if I say this is the line and the other line, so can I say now this part is what, a point of concurrence you're getting? There should be three lines, minimum of three lines, not the two lines. Two lines always intersect, always intersect. That is not the point of concurrence. There should be three or more lines, right? So that is known as what, beta? Points of concurrence, right? Now let's do one illustration. Use the figure, name the 5 points, a line, a four rays, and a line segment, right? Okay, so 5 points are what, beta? What are the points? The points will be what? Just see over here. The points, I'll just write it over here. The points will be what? This is the point D, this is E, this is O, this is B, and this one is C, right? So point will be what? D, E, O, B, and C, right? So if I say about the line, how many lines you see? You see that a line DB? Yes or no? DB line or BD line? Yes or no? You can say that EO line also, right? But we'll take the extreme endpoint. So just to indicate all the points which are lying inside it, it's like that. Okay. So let's talk about the rays. What are the rays? So rays will be what? One ray is what? OB, right? Other ray is what, beta? OD, right? The other ray is what? OC. Yes or no? And if you just take this point as P, so this will be what? OP ray. But it's not given, so we're not going to write it, right? Now it says that 5 line segment, right? So line segments, right? What will be the line segments, right? So you will get the questions like this. How many line segments you get? DE, right? Now DO. Now I'm just taking the D point as a fixed point, right? Now DB, right? Now take the point EO, right? EO, EB, right? Take from E, right? Now you take OB, right? This is a line segment. Then OC and OP. These are what? A line segment, right or not? Yeah, it's going towards right, but line segment is this, right? Oh, I'm writing this. Sorry. Don't take OC and OP because we have already taken that as a ray. So don't take OC and OP. Okay. Hmm. I wrote more than 5, right? I wrote 6. It should be 5, right? So it is DE, DO, DB, EO, OB. I wrote what? 1, 2, DO, DB, EO, and EB. I think so. OB they have not taken because they have considered this as a ray, but they have considered OB. Oh, wait a minute. OB, OC, OE, OB, OC, OE, DE. I'm correct. That's correct. Leave it. It's correct. You can write it like that also. It says that any of it, right? So I wrote many of it. Doesn't matter. Right. Now it says that use a ruler and check which of the following points are collinear or not. So just you can take the scale and see. DAC, right? DAC. This is not a straight line, right? DAC non-collinear. If it's wait a minute. If not collinear, then it's non-collinear, right? Non-collinear, right? A, B, C. Again, if you're going to measure this, A, B, C, right? So again, non-collinear, right? A, B, E. A, B is a line in a straight line, so it is what? A collinear. B, C, E. It's again not non-collinear, right? Okay, coming to the angles. What are the angles, right? What are the angles? Angle is nothing. If you take any two ray, right, the ray has been like starting from here and it's like going ray 1 and this ray 2, and this is being formed. This is known as what, beta? An angle, right? An angle is said to be what? An angle is all can be also called as the corner, or by this an angle is made when the two or more rays are starting from the same vertex, right? So can I say that this is a ray, right? This is an angle, right? Can I say that this one is an angle, right? Can I say that this one is an angle, right or not? Yeah. So can you see that this one is again, oh my goodness, where's my pen going? This one is an angle, right? If you open a laptop, right? If you open a laptop, so this is an angle. Crocodile mouths is an angle, right? So you see that the intersecting roads are what, beta? These are what? Angles. These are what? Angles, right? If you see in a clock also, this is what? An angle. The scissors, yeah, this is a scissor, so this is what? An angle, right? So it means what? These are said to be what? Basically, ray 1 and ray 2 are what said to be what, beta? Arms. This is what are the arms of an angles, right? We say these are the arms. So here you can take a two ray, you can take a two line segment as well. So if you take the two line segment, the line segment, this is a line segment AB, and this is a line segment, this is AB, and this is AC. So this is what? An angle. This is what? An angle, right? So the angle can be like, see, common vertex, say you have to take the angle and you know how to write the angles and you know what is an interior and the exterior of the angles, right? Okay, see, let us suppose how we are going to write the angles, right? Yeah, I'm naming this as O, this is A, and this is B. So we have to name this angle. So either you can write this like this as angle BOA or angle AOB. You can go in the clockwise direction, you can go in the anti-clockwise direction, choice is yours. Or you can write this as angle O all alone. But if the figure is made like this, let us suppose if the figure is okay, if the figure is made like this, right? This is O, this is B, and this is A, and this is like this is C, right? So if I say that there will be two angles, this is what? Angle 1, right? And this one is angle 2, right? So angle O is not written like directly angle O, right? Angle O will be written like this. So angle 1 कैसे लिखा जाएगा बेटा? Angle 1 will be written like this. It will be what? Angle BOA or angle AOB, right? Angle 2 will be written like this. It can be written as what? Angle AOC or angle COA, right? And angle O will be written as what, beta? Angle 1 plus angle 2, right? Angle 1 plus angle 2, right? Which is equals to what? Angle O can be written as what? Angle COA plus angle AOB. Got it or not? Yes. Now, there is one more thing you should know, what is an interior and the exterior of the angles, right? So, now let us suppose this is an easy question. Now, let us suppose if I say, right? So, this will be what, beta? Interior of an angle. Yeah, I'll take the points, right? It's better I'll take the points. It will be more easier to understand, right? Okay, this is an angle, right? Yeah, I've named this as P, this is as Q, and this as R, right? Okay, I'm taking this point as A, this point as B, and this point as C. So point A, the point A lies where, beta? The point A lies in what? Interior? In interior or not? Interior of angle? Yes, point A. Yeah. Point B will lie with a what? Point B lies on the arm. Yeah, lies on the arm. Yes, lies on the arms. Yes or no? And the point C will lie beta where? The point C lies in the exterior of angle. Yes or no? Yes? Or we can say the arms or on the boundary, whatever you feel like, arms or the boundary, right? Both will work, right? Coming to an illustration, what is an illustration? It says that name the angles given. So there are many angles given. This is angle A, this is angle B, this is angle C, this is angle D, right? So you can write this as angle A. I'm writing this angle D, right? So how you're going to write angle D? You can write angle D, ADC, or you can write angle CDA, right? Angle A can be written as what? Angle DAB, or it can be written as what? Angle BAD, right? Now, angle B can be written as what? Angle ABC, or it can be written as what? Angle CBA, go in any of the direction. Angle C can be written as what? Angle BCD, or it can be written as what? Angle DCB. You can opt any of the options, right? Okay. Now, let's coming to the curves. What are the curves, right? So, curve means what? Nothing now. Curve means simply nothing. Like since your childhood, you have been doodling your like sheet of paper when you don't know how to write the alphabets. Even your parents have would have given you a sheet of paper just do doodle on your paper. Just do whatever you want to do, right? So it means what? A curve is something which you doodle without lifting a pen, right? You are not allowed to lift your pen. Let us suppose I made a figure like this, like this, like this, like this, like this. Yes, you can just go once again over here, right? So like this, right? But I did not lift my pen. But if I'm going to make this figure, this is I lifted my pen. So this is not a curve. But without lifting a pen, going in the one direction, so curve can be defined as a continuous movement of a point in any and every direction without lifting pen. I'll write this without lifting pen, right? Lifting pen, right? So without lifting pen, you have been doodling around your life and you know what you have been doing it, right? So you just doodle it like this, 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 like this is a curve, right? So you make this, right? So you make a leaf like this, like this, like this, like this, right? I'm making like this. Okay, I just lifted my pen, so this is not a curve, right? So this, like this, and then like this, like this. You just make a figure. Like, see, many figures are made, so you don't have to lift the pen, right? So there will be some specific definitions about the curve, like how what type of the curves you have, right? So you just write down the definition first. Okay, okay. First is that the curve which have different beginning and end, different beginning and end points are called open curve. Open curve like this. I started from here. I doodle, 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 and I stopped here, right? So this is I started. This is where I started, right? And this is where I end, right? So this is known as, like, let us suppose I started from here, here, and here, and I ended over here, right? So I started from here and then like this, like this, like this, and then I stopped over here. So these are what beta open curve, right? Now, coming to the definition of what is a closed curve, right? The curve which have the same beginning and the end points are known as what? Beta closed curve, right? The curve, the curve which have same beginning and the endpoints are called closed curve. Closed curve का simple से example is what? Like this, you draw a figure like this, like this, like this, right? Draw a circle like this. You don't know. You started from here and then you don't know where you are ending, right? You started from here, you are ending, right? So you started from here, here, and then you came back to this position. So these are known as what a closed curve, right? Now, what do you mean by a simple curve? Simple curve means what? There should no be overlapping, right? There should be no overlapping. Okay, so what's the next definition? The curve which does not, which does not, you will be learning the same definition in class 8th again. But let's see how many of you are going to remember this, right? Does not cross it itself at any point is called simple curve. It should not cross each other, right? Simple curve, right? So it means what? You cannot cross. Like if I just made a figure like this and like this, I just crossed it. So no, this is no. But it should be like this. If I started from here, then goes like this, like this, like this, like this, like this, and like this. I came over here, or I went like this. I like went like this, like this, like this, like this, like this, and just stand it over here. Right. So this can be a what? A simple curve, a curve which does not crosses each other, right? And the curve which crosses each other are known as what, beta? A non-simple curve, right? Yeah. Okay. So the curve which crosses each other, I can just write this. The curve which crosses each other, which crosses cross each other, or each other is called non-simple curve. Yes, non-simple curve like this. If I just draw the figure like this, like this, like this, and I made a star like this is what? It's crossing each other. These are what? Crossing each other. Yes or no? They're crossing, yes or no? So when they're crossing, so they are not said to be what? A simple curve, right? Okay, so let's see what is the difference between a straight line and a curve, right? A straight line and a curve means what? If you see that in a maths, you might be thinking that if you see this, right? So over here, you see that this is a figure, this is a straight line. Can a straight line be a curve? Yes, a straight line is a curve also, right? If you draw like this is a curve. But mathematically, we say that curve is like, see, a straight line is the shortest line which can join any 2 points, right? And a bent line which is not a straight line is not a curve. Like anything which is bent is like a curve, right? But a straight line is also a curve, right? We say that it is a curve, but it is a shortest distance, right? So like I said, and a straight line always moves in one direction, and this does not move in one direction. Not necessary that it moves in one direction, right? So till now we have been doing the questions like either it's going in the left or it's going in the right. Right now we have been doing the question like line segments, flat surfaces, everything. Right now, as I told you, like A say B, right? A say B, you can go this in a straight line. So this is again a curve, but you can go like this, like this, like this, like this, like this, like this, and coming back to B, right? So this one is a what? A curve line, and this one is a what? A straight line, right? But we can say that a straight line is also a curve in the mathematics, right? Straight line is also a curve, but we generally say that it is a straight line which is a straight, like going in a one single direction and moving in one direction, and a curve is means which does not like goes in a straight line, it's a little bit bend, we say the curve, right? So just to make us self clear, if I made like this and I made like this, so everyone can say that this one is a curve, right? And this one is a what? A straight line, right? Okay, just a second here. I'll keep you on mute for 1 minute. I really need to do it. Just a second. Just a second. I really need to do one mess. Just a second here, okay? Okay. Now, what is a polygon? Now we are on the polygon is means what? A polygon is a closed figure bounded by three or more line segment intersecting to form a closed curve. What do you mean by a closed curve? Right now we have just made a closed curve means what? You don't know what is the beginning and what is the end point, and it should be a simple curve also, right? It should be a closed as well as what? A simple curve. It should be what? A simple curve. You can just say like right now I made a star, right? So I made this star with a line segment also, right? This is a line segment, right? All these lines are what? Line segment. But this is what? It is not a polygon, not polygon, right? So polygons are always made, the polygons are always made like it is a closed figure. It is also closed, right? Bounded by three or more line segment, yes, intersect exactly to form a closed curve, and it should be a simple curve, no overlapping of itself, right? So if I give you a two straight lines, can you make a like a closed figure? If I give you like two straight lines, this a line and this line segment, right? A line segment, this, can you make any closed figure with this? No. But to make a closed figure, you require minimum of the three line segment, and the minimum three line segment always lead to you to what? A bit a minimum of triangle. A triangle will be formed, right? So the curve has to be what? A simple, right? So you say that a three line segment polygon, this is what? Six side line segment polygon, this is four side like line segment polygon. So if I make a like this figure, like this figure, like this figure, so this is this is what? This is what? Five line segment, right or not? Five line segment, right? It should not be overlapping. So can I make this figure also, right or not? This is again a what? Polygon, yes or no? This is again a polygon, right? Can I make this as this and this is a polygon? No, this is not a polygon because it have a curved surface, right? So if I make a polygon like this, like this, like this, like this, and like this, so this is a polygon. Yes, this is a polygon, right? This one is, yes. So these are said to be what? Beta a polygons, right? Okay, so these are the terms related to the polygons that you should be knowing about it. Okay, so the terms in the polygons are said to be like, if I make a polygon like, see, this is A, B, C, D is a polygons are made, right? So what are the, like, you just read it out and write it down this as definition. The line segment that forms a polygon is said to be a sides, right? So if I make this and I draw like this and like this and like this. So this are what? Beta sides? Yes or no? Now, what are the vertices? Vertices means what? The angles. Here the angle is made, here the angles are made, here the angles are made, where the angles are made. So these are what? Beta vertices? Yes or no? So how you're going to write the side? Side will be what? If you see the figure, the side will be what? AB. It will be what? Beta BC. It will be CD. It will be AD. Vertices क्या होंगे beta? A, B, C and D. These will be the vertices, right or not? These will be what, Peter? Vertices. Now, adjacent sides. Adjacent side means what? Bagal wala. Bagal wala means what? Just next to you, right? So if your teacher said who is sitting adjacent to you, like if you say if your best friend is sitting adjacent to you means what? Who is sitting next to you, right? It can be on the left hand side and it can be on the right hand side, right? So adjacent side, if you talk about the adjacent side, right? Adjacent side, so the meeting of the two side is the term as like, if you see the vertex, right? So if you take the vertex D, what are the two sides that you have been produced? That it is what? DC and AC, right or not? So you have to just, adjacent sides always exist in a pair, right? So can I say that these are what? Adjacent sides. So if I write the adjacent side, it will be taking the D as vertex, so it will be what? Beta DC and DA, right? These are adjacent side. Take the vertex A, so it will be what? AD, and it will be what? AB, right? Take the vertex B, so it will be what? Beta BC and BA, right? Or it can be what? Take the vertex C, so it will be what? CD and CB, right? Now, what are the adjacent vertices? Adjacent vertices means what? That the two vertices, like if you take the vertices, the end points of the same side of the polygons are said to be what, beta? Adjacent vertices, right? So if you take the end points, right, these and this, right? So C and D are adjacent, right? DK adjacent will be what? C and B, right? So you have to take like adjacent vertices will be what, beta? Adjacent vertices will be what? Vertices will be what? It will be what? D and C, right or not? Yes, DC. Yeah, these are adjacent, right? Can I say that CB, right? Can I say that AB, right? These are adjacent. Can I say that AD? Yes or no? They are adjacent to each other. DC are adjacent to each other, right? So these are adjacent. What are the diagonals? Diagonals are what? Let us suppose if I have made a figure. So from vertex D, say if you're going to C and if you're going to A, this will be your sides. This will be your sides, right or not? This will be your sides. But if you're touching the other vertex will be what, beta? A diagonal. This will be your diagonal, right? So your diagonals are what, beta? AB, AC, and BD. I'll give you one again example of the other figure. I think so for you, just to make the diagonal things clear. I'll make a figure like this, like this, like this, like this, and like this, right? So this is what a polygon with the five sides. So A, B, C, and D, and this is E. Now you have to find that, right? Like find numbers of diagonals, right? Find number of diagonals, right? Number of diagonals, right? So find number of diagonals. How many diagonals are there? So take the vertex. Take vertex from vertex A. So vertex A, AE, and AB will be what? Your sides. So your diagonal will be what? AD and AC. Yes or no? It will be what? AD and AC, right? You will be not counting again and again. Once you have just taken it, you will not count it again, right? Now take the vertex B. Vertex B, right? So AB and BC are what, beta? These are your sides. So ABE and BD will be what? Your diagonals, right or not? BE and BD will be your diagonals. Now take the vertex. Now take the vertex C. Now from the vertex C, BC and BD are your sides. Now CA and AC are same. You have already written one diagonal. Now only one diagonal you have to attach, that is CE, right or not? So it will be what, beta? CE, right? AC is already written, so you don't have to write it again. Now take the vertex D, right? Take the vertex D. So what are the diagonals you get? So from the vertex D, DE and DC are your sides. So DA, DB will be your diagonals or not? So DA, it's already written, and DB already written, so no need to write again. No. Okay, not taking the vertex C, it's already made, so no need to write it again. So vertex E, if you're going to take, ED and EE are what? Your sides. So EC and ED will be your diagonals or not? So total diagonals will be what? Total diagonals will be how much, beta? Your diagonals will be what? 5 diagonals? Yes or no? Yes. Now coming to the illustration. Is it possible that each of the following with a diagram, a closed curve that is not a polygon? A closed curve that's not a polygon, it's any polygon you can make, beta. A closed curve, it should be closed. So make a circle. Yeah, make like this. Yeah, it's not a polygon. A polygon with this two side is possible. Yeah, this is the first part. So second part is what? No, it is not possible. No, it is not possible to have polygon with two sides, right? So it cannot have, right? Okay. So now we have done with the lecture number 1. So we'll be doing the lecture number 2 in the next class, and then we'll be finishing up with this chapter. And if you have any doubt, we'll be doing more questions in the next class regarding this chapter. If you have any doubt regarding this chapter, you can always ask it on the board PDF. That's batch discussion forum. And always you can raise your query in the class itself and ask your class teacher what it is and what it is not. So thank you, class. We'll be seeing you in the next class. Okay.